Hello, it's Dumplet here. Welcome to the sixth episode of Dumplet Tutorials. Tutorial number 6 and number 7 will be talking about common series and the shortcuts, or like the formulas that you can use to help you speed up your solving process in some national and international Olympiads. Just like, for example, here, part 1 will be discussing 3 of these. Now, one of these is shown on the screen. Now, there is a lot of formulas for certain series and whatnot, but the most common series are these 3. So as you can see, it's the sum of the first n something. It's the first one is the sum of the first n positive integers. The second one is the sum of the first n positive perfect squares. And the third one is the sum of the first n positive perfect cubes. Now, there isn't really a nice way to remember these formulas unless you're going to really memorize these formulas. So have a go, try to memorize these formulas, and we'll go to some examples just to show you like how these formulas work. Now, also the similarity, notice the similarity between the first one and the third one. So it's kind of interesting that if I square the sum of the first n positive integers, I will be getting the result, which is equal to the sum of the first n positive perfect cubes. So this is kind of a nice relationship between the first and the third, and I believe like the second one is the most difficult to memorize. But it's just a formula, so nothing really too fancy about that. And guaranteed, knowing these, it's going to help you a lot in solving questions such as the ones that I'll be showing you guys. So let's try to do some examples using these 3 formulas. Right, but just pause the video if you want more time to memorize these formulas before you move on. Alright, so for the first one, very simple, 1 plus 2 plus 3 plus 4. Well, sure, we don't really need the formula for that, right? 1 plus 2, that's 3. 3 plus 3, that's 6. 6 plus 4, that's equal to 10. So, I mean, sure, we can do this without even the formula. But let's just try to show that the formula actually works. Now, this is the sum of the first 4 positive integers, so we're going to use the first formula, the blue formula. So n times n plus 1 all over 2. But we're now getting the sum of the first 4 positive integers. So n here should be equal to 4. So I should substitute n equals 4 into the formula. So if I substitute n equals 4 into the formula, it's going to be 4 times 4 plus 1, that's 5, divided by 2. Now I can cancel the 4 and the 2. That's pretty nice. So it's just 2 times 5. And I'm going to end up with 10. So indeed, 10 is indeed the answer. So 1 plus 2 plus 3 plus 4, either just by adding them one by one or using the formula n times n plus 1 all over 2, you're going to get 10. Alright, for the next one, try to give yourself some 10 seconds to try to answer this question. And let's now dive into the solution. Now sure, we can add them one by one, but you see if there are more terms, for example, if this 10 was a bigger number, like 2021 instead, well, then you do not really want to add those numbers one by one. So knowing the formula, again, recalling the formula n times n plus 1 all over 2, knowing this formula really helps. So we're trying to get the sum of the first 10 positive integers, so we're going to substitute n equals 10 into the formula. Now if I substitute n equals 10, I'll be getting 10 times 10 plus 1, that's 11, divided by 2. Now cancelling the 10 and the 2 because they both have a common factor of 2. So I'm just getting 5 times 11, and that's equal to 55. Now you can manually check it, you can manually verify it on your own, but indeed 1 plus 2 plus 3 plus so on and so forth until plus 10, that's indeed equal to 55. Alright, now let's try to do the next ones. So after the sum of the first n positive integers, let's try the sum of the first n positive perfect squares. Now surely we can evaluate it one by one. Okay, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Then surely we can do, just add them one by one. 1 plus 4 equals 5, like 9 plus 16 equals 25. So I'm just getting 5 plus 25, and that's going to be equal to 30. So we should expect 30 from the result. Now we're going to use the green formula. Now recall the green formula, n times n plus 1 times 2n plus 1. It's also nice how n and n plus 1, if you add those two together, it's going to become 2n plus 1. So you can try to include that as a way to memorize this formula. And we're just going to divide the result by 6. which is coincidentally equal to, if you want to say that it's equal to 3 factorial, well, sure, you can do that. But anyways, this is the formula that we have, n times n plus 1 times 2n plus 1 all over 6. Now we're asked to get the sum of the first 4 perfect squares, so we're going to have n equals 4 in our substitution. Now if n equals 4, this becomes 4 times 4 plus 1, that's 5, times 2 times 4 plus 1, so 2 times 4, so the 2n becomes an 8, 8 plus 1, it's going to become a 9, and divide the result by 6. Well, the 4 and the 6 will cancel, so 2 and 3, and then the 3 and the 9 here will cancel again, so 1 and 3. Now 2 times 5 times 3, indeed, we're going to get the answer of 30. 2 times 5 is 10, and then 10 times 3 is indeed 30. Alright, now sure we can, sometimes it's kind of easier to just add them one by one, but for example, if I gave you something like this, well, 1 plus 4 plus 9 plus 16 until 400, well, that's a lot of numbers, so you don't really want to add them one by one. Now, although it's not really obvious that this is the sum of squares, but the numbers here are kind of familiar, I can just rewrite the following. So 1 is just 1 squared, 4 becomes 2 squared, 9 is 3 squared, and you guys can see the pattern here. And the pattern, so we're getting the sum of the first 20 squares, because 400 is 20 squared. So recall the formula, n times n plus 1, ugly handwriting over here, n times n plus 1 times 2n plus 1, divide this result by 6, so we're going to substitute 20. Again, sometimes the numbers are going to get a little bit bigger, but don't worry, you can just take your time in doing this. It's a lot better than just adding all of these one by one anyways. Alright, substituting n equals 20, because we're asked to get the sum of the first 20 squares, so 20 times n plus 1 becomes 21, 2n plus 1, that's 2 times 20, which is 40, so 2n is 40, we add 1, so it's 41, and we divide the result by 6. Again, we can use cancellation. The 6 and the 20, it becomes 3 and 10 over here, and the 3 and the 21, it becomes 1 and 7, so it's a little bit big. So 10 times 7 times 41, so 10 times 7, that's 70, so we can do a little bit of multiplication here. 70 times 41, okay, we can take down the 0, 7 times 1, that's going to be 7, 7 times 4, that's going to be 28, so 2,870. So although it's kind of a big number, but the sum of the first 20 squares is indeed 2,870. Now you can verify this on your own, but indeed the answer is in 2,870. So that's already a nice indication that you save more time. You save a lot of time by not having to add all of these one by one, because some competitions, they actually require you to get these, and it's actually very common for national and international competitions to get these types of sums, because although they might not really ask directly, like the sum of the first 20 squares, but like the solution to some problem might involve something similar to these. Alright, without further ado, let's try to do the sum of cubes now. Again, we have the sum of cubes, but surely let's just try to do it manually by hand first, just to see. So 1 cube is 1, 2 cubed is an 8, 3 cubed is 27. So 1 plus 8, that's 9, plus 27, that's 36. So I should be expecting 36 from the formula. Now recall the formula, it's just a blue formula, right? Recall the blue formula, but we're going to square the blue formula. So that's kind of a nice connection between the sum of the first n positive integers and the sum of the first n positive perfect cubes. So anyways, we have to substitute n equals 3 because we're asked to get the sum of the first 3 positive perfect cubes. So this is going to be equal to, so we have the bracket squared. Now inside becomes 3 times 4 divided by 2. Now the 2 and the 4 cancels nicely, 1 and the 2 here. So it becomes 3 times 2 inside. Now 3 times 2, it results in 6, which is also the sum of the first 3 positive integers, because 6 is just 1 plus 2 plus 3. So you can kind of see the relationship there. Now anyways, to answer the question, 6 squared, that's indeed 36. So we have 36 in both cases, either doing manually or using the formula. Now try to do this one. It's a little bit bigger, but the sum of the first 50 positive perfect cubes. Again, you do not really want to evaluate it one by one. I mean, I myself don't really memorize perfect cubes, like greater than 10. So it's going to get tedious and very tiring real quick. So having the formulas is indeed nice. Right? Recall the formula. We have the blue formula inside of the brackets before squaring it. So blue formula inside the brackets, and then don't forget to square it. Now we're asked to get the sum of the first 50 perfect cubes. So indeed n is going to be equal to 50. We directly substitute it inside. So this becomes, so the brackets remain here. So it becomes 50 times n plus 1 becomes 51, and we're going to divide the result by 2. The 2 and the 50 here cancel pretty nicely. So inside we're going to have 25 times 51. It's a little bit big, but it shouldn't be too much of a problem. Just do simple multiplication. So 5 times 1, it's going to be 5. 2 times 1, that's going to be 2. 5 times 5, that's going to be 25. But we carry the 2 for now, so carry the 2. 2 times 5, that's going to be 10. Now don't forget to add the 2. So we're going to put here, instead of 10, we're going to put 12. So just simple multiplication back in elementary school, and we're going to get that 25 times 51, that's 1,275. So that's just whatever we have in the inside here. So whatever is inside is equal to 1,275, and then we're going to actually square it. Well, it is kind of expected because the numbers are getting a little bit bigger. But then again, doing this is way better than just doing all of these one by one. So just for the last step, let's try to get 1,275 squared. Again, this is just simple multiplication, but I'm not going to do everything by hand here. I'm just going to tell you guys beforehand that the square of 1,275, this will be equal to 1,625,625. So indeed, it's a big number, but I assure you, doing this is way faster than calculating all of these cubes one by one and then adding them all together. All right, so this wraps up part 1 of some of the common series and the shortcuts and the formulas that you might see in national and international competitions. And I'll see you in Dumplet tutorial number 7, or just the part 2 of the common series. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!